Hello, we're going to take a look at 7-5 worksheet day 1 through 19 odds, finding all solutions. So we have to keep in mind that if there's a point that is a solution on the unit circle or an angle, that angle is a repeated answer due to the fact that sine, cosine, and tangent functions don't end. They're cyclic, they repeat. Anyway, so let's go ahead here. First of all, we're going to subtract 1 over here. And again, that type of step you don't have to always write down. Okay, and then let's take a look on the unit circle. Where is the x value, -1? It's over here. So that means x will need to be pi. And if I go around 360 degrees, that's going to be 2 more pi. And we can do that k times, where k is any integer. We'll just add that for this one, for any integer k. So this whole thing is my answer. So if k is 0, my answer is pi. If k is 1, it's going to be 3 pi. If k is -1, it's going to be -1 pi. So again, that's kind of how we roll with these. I'll just switch colors here. Here I'm going to subtract the 1. I'm going to add the 1 over. And then I'm going to divide by 2. So I'm going to get sine x equals +1/2. Again, on the unit circle, where is sine 1/2? It's here at pi over 6. And it's also here at 5 pi over 6. So, like the previous one, we can say that we're going to get pi over 6 plus 2 pi k, meaning I can go around and around. And it's going to be 5 pi over 6 plus 2 pi times k. And again, I'm not going to write each time that it's for any integer k. Alrighty, so that's kind of how we do it here. We end up with these solutions on the one unit circle, but then we have the other solutions as we continue around here. So this one here, I'm going to change colors again. I'm going to go here. I'm going to subtract the 1 over, and then I'm going to divide both sides by √3. So I'm going to get tangent of x equals -1 over √3. And again, this is going to be, again, checking my unit circle, it's going to be here, and it's going to be here in this case. So we have 2 spots on the unit circle. So this second quadrant spot is going to be at 5 pi over 6. And again, since these are diagonal of one another, I'm going to say 2 pi k. And x can also equal -1 pi over 6. That's this one right here, plus 2 pi k. So again, we have these kind of spots here, and we can kind of cover them from there. Alrighty. Alrighty, changing colors again. Let's go green. I'm going to subtract, I'm going to add the 1 over, divide by 4, so I'm going to get cosine squared x equals 1/4. I'm going to square root both sides. I'm going to get cosine x equals plus or minus 1/2. So now the unit circle here, cosine +1/2, -1/2, -1/2, +1/2. So we have kind of 4 spots, but these are pi apart and these are pi apart. So we can kind of do some work there. So if I'm going to start here, I'm going to say that x equals pi over 3. And I could go, instead of 2 pi around, I can just go 1 pi around for that one. Okay. Now this one right here is 2 pi over 3. And since I have one kind of halfway around from that, again I can use that pi over k instead of 2 pi over k. So that takes care of all of those. So kind of continuing on here, I'm going to add the 2 over. I'm going to add the 2 over, so I'm going to get secant squared x equals 2. Again, that's 1 over cosine squared equals 2 over 1. I'm going to flip both sides, so I'm going to get cosine squared equals 1/2. And I'm going to square root. And when I square root this, I'm going to get cosine squared equals plus or minus 1 over root 2, but that equals plus or minus root 2 over 2. Okay, and on my unit circle, plus or minus root 2, that's going to be here, 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 and here. So we have these 4 spots, but we have pairs of them which are diagonal one another. So I'm going to say x will equal pi over 4 plus pi times k to get these two, first and third quadrant. And then I'm going to say 3 pi over 4 plus pi k, because I'll have kind of opposite ones there. Okay. Now there are ways that we could kind of combine these, but right now these are just fine here. Okay. Alrighty. Moving on here, cosecant. So I'm going to add the 4 over, divide by 3. So I'm going to get cosecant squared equals 4/3. I can square root here if I want at this point. So cosecant x equals plus or minus 2 over root 3. And cosecant is 1 over sine, so I reciprocate. So I get sine of x equals plus or minus root 3 over 2. So again, my unit circle view of this is going to be here, 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 and here for my sine values. Again, I've got these kind of diagonal ones here. So I'll change colors here. Should have did that already. So that means if I'm looking here, it's going to be x equals pi over 3 plus, and now since I have one diagonally, I can just say pi over, or pi times k. And then if I go ahead and look at this one, that is 2 pi over 3, and since I have 1 over 180 degrees or pi units away, I can say plus pi over k. So those are my x's here. Alrighty, so moving on. Let's change into maybe kind of orange. Now, these ones we get a little bit different. Since I've got this times this, I can use the zero product property and say I have this, or I'm going to have 2 times sine of x plus 1 equals 0. Now this one's ready to deal with. Now this other one, I'm going to subtract the 1 over, divide by 2. So I'm looking at sine of x equals negative 1/2. Over here, cosine 0 is going to be here and here. So I can say x will be pi over 2 plus pi k, since I have 1 pi units away. Over here, I'm going to change colors here. I'm going to go ahead. Negative 1/2 for sine is going to be here and here. And so that's Okay, those are not diagonal one another, so I'm going to have to do these separate here. So this is going to be 7 pi over 6 plus 2 pi k. And then this one here is going to be 11 pi over 6 plus 2 pi k. So all of these give me all of the solutions. Continuing on here, let's go purple. Again, zero product property here. I can say tangent x plus root 3 equals 0, which gives me tangent x equals negative root 3. And we know that negative root 3 is at the 2 pi right here. So I can say that x here is going to be 2 pi over 3 plus 2 pi k as I go around and around. And if I change colors here to this guy here, so that means that cosine x is equal to negative 2. Again, that is not possible because it's undefined. Cosine's maximum value is 1, minimum value is negative 1. So this, for number 15, is my only solution. Oh, wait a minute here. I could also get it here, and so I can cross that out here. Sorry about that. Last couple here. This one here, a little different. I can factor it. I can take the cosine out of both, because cosine is a common factor. And now again, I can go cosine x equals 0 using the zero product property. Again, looking at where my cosine is 0 is here and here. So that's going to lead me to say that one set of solutions is going to be pi over 2 plus, since I've got another one diagonally to it through the origin, I can call that pi k. This other one, I'm going to get sine of x equals 2. After I get sine of x minus 2 equals 0. And again, this is not possible, so this is undefined. So that means for number 17, this is my only solution, set of solutions. Okay. And then moving on here, let's go back to blue. Again, factoring problem here. So I can do 2 cosine x minus 1 equals 0. This is a squared binomial. So in either case, I'm going to get 2 cosine minus 1 equals 0. Add 1, divide by 2, so cosine x equals 1/2. Unit circle can be here and here. They're not diagonal, so I'm going to have 2 solutions here. So just to break this one up here, oh, I'm not going to use that color. So for this one here, that's going to be x equals pi over 3 plus 2 pi k for going around and around. This one right here, I can call that negative pi over 3 if I wanted, or I could call it 5 pi over 3 if I wanted. I can go either way here, so I'm going to go here with 2 pi k. Alrighty, so again, we do have some options here. I could have done 5 pi over 3 plus 2 pi k or k pi. Okay, so either these two or this one and this one. So there you go, kind of dealing with solving equations and finding all the solutions.